Okay, so today we're having fourth class of thermodynamics, fourth lecture. In this lecture, we will study about the work done in adiabatic process, and we will sum up all the work done in all the processes. Okay, got it, everyone? Okay, but before that, we will try to solve some problems based on what we have studied in last class. Okay, so this is the first problem, everyone. This is the first problem that we have studied in last class. Okay, try out this problem, everyone. Just try out this problem. For now, okay, for now, just consider delta H. Okay, we will discuss what is delta H, by the way. Delta H is equal to Q at constant pressure. Constant pressure. Okay, as simple as that. Try to solve this problem, everyone. Till everyone join, just try to solve this problem. Everyone should try. Everyone should try problem number 8. This is based on what we have studied in last class. Okay. Have you solved? Have you tried? Everyone? Anyone who has tried? Okay, Abhiram has tried. What about anyone else? So see, what is given? First of all, whenever you are asked to solve some problem, you have to know what is given, right? What data is given. Okay. So just try to write the data what that is given. So we have N is equal to 1 mole expanded isothermally, right? So process is isothermal. Isothermal. Okay. From 10 atm to 1 atm. So P1 10 atm, P2 1 atm. Temperature it's already given 300 Kelvin, right? Calculate Q, W, delta U and delta H under the following condition, right? Forget about delta H for now, but we can calculate Q, W, delta U. So let's calculate W for now, okay? Because when we talk about delta U is 0, right? Because it is isothermal. So you don't have to calculate delta U because it's a 0. So first thing we have to calculate is W. Now just think about this. for isothermal process and number of moles constant, can I say that P1 by P2 is equal to B2 by B1? Yes or no? Tell me. Yes or no? Yes. So what is the work done? Formula of work done for reversible process. We know that it is minus 2.303 nRT, n is 1. So RT log V2 by V1. Now V2 by V1 can be written as P1 by P2. Yes or no? As simple as that. Got it? Right? So this was the concept. Since it is isothermal process, V2 by V1 can be written as P1 by P2. Got it? Tell me, can you solve this? Right? Because log base 10, है ना? Base 10. P1 is 10, P2 is 1. So it is log 10 by 10, which is 1. So W will just be minus 2.303 into 8.314 into 300. Okay, so this value, right, this value you should remember. Okay, instead of multiplying every time, you just remember the value of 2.3 into 8.3. Okay, right, then into 300. That will be your answer. Yes or no? Tell me yes or no. Got it? Right, everyone? Did you get the concept? Very good. See, same thing is being done, right? Anna, same thing is being done. Okay. Now what about irreversible expansion? Think about this. What about irreversible expansion? We have studied now, right? We have studied the formula. Tell me, how many of you remember? For irreversible expansion, right? For irreversible expansion, the formula will be for isothermal process, right? So work done for irreversible process. Irreversible is equal to minus nRT tell me just P delta V है ना P delta V got it so P delta V can be written in terms of B can be written in terms of pressure yes or no yes or no yes very good now this you have to remember okay for irreversible process the pressure will change right very fast yes or no right pressure will change very fast right so I'm having formula as P external into V2 minus V1 yes or no so this can be written as minus P external into nRT by P2 minus nRT by P1 yes or no tell me yes or no but if I'm saying that in irreversible process pressure change suddenly right or pressure change take place very quickly so what we will take as P external tell me what we will take as P external we will always take P2 as P external. Okay, because just imagine if pressure is changing, right? It will change like this. So P1, P2, it will change to P2. This may not be the exact graph. I'm just trying to understand. Okay, right? I'm just trying to make you understand. Now, if you talk about the area, so can I say that the area will be closely equal to this area? Yes or no? Where this is V1, V2, and this is P2, right? So the area would be P2 into this V1 mass V2 mass V1. Got it? That's why P external will be taken as P2. So minus P2 into nRT by P2 minus nRT by P1. Got it, everyone? Minus. Okay? Got this? Yes or no? Tell me. Everyone got this? Okay? So it will be nRT minus, right? P2 by P2 minus P2 by P1. That will be your answer. Got it, everyone? You can solve this, right? So see, this is your second answer. Okay? Minus 270 R. Right, everyone? Okay. So we'll solve next problem based on same concept. I hope all of you understood this problem, right? Okay, try to solve this problem now, right? Try to solve this problem. Everyone, try to solve this problem. Can you see the problem? Everyone can see the problem, right? Okay, very good. Write down the information which is given, figure out what is the process, then forward, right? है ना? Step by step. Okay. So first thing that you should ask yourself, that this is reversible process or irreversible process. Okay, Namika? Yes. Reversible or irreversible, then it is irreversible. Why? Because it is said that work is done in single step, right? So this is your irreversible process, because we know that, if you remember the concept taught in last class, that in reversible process work is done in infinite steps, not in finite steps. Okay. Yes, Neha. Total work done will be 110. Right. See, try to understand the problem. All of you are solving it correctly. Okay. Right? All of you are solving it correctly. But there's some misconception. So first, we have two steps. Right? First against 5 ATM, then against 2 ATM. CA, answer is wrong. Right? So try to start with first against 5 ATM. Okay, just think about this now. This is your external pressure. So work done is equal to minus P external into V2 minus V1. Yes or no? Now in first case, P external is 5 ATM, right? So if P external is 5 ATM, then we will have minus 5 into volume is changing from 50 to 10. So 50 minus 10. Got it? Right? Right, everyone? Okay? This is what you might have done. But what is mistake here? Tell me. What is the mistake here? What is the mistake here? There's a small mistake here, right? This is something that you guys should have done, right? But there's a small mistake here. The mistake is V2. This V2 is at 2 ATM, right? So this is not the V2, because we have to find V2 at 5 ATM. Got it? Right? So we have to find this as 5 ATM. Got it? So we will solve 10 by 10 is equal to, or you can just use Divisible and RT. Okay, right? This V2, yes, Jasharan. After solving this, V2 will be 20 liter. Got it? It will be 20 liter. Okay, so instead of writing 50, you should write 20. This is 20 because this V2 at 5 ATM now. I already told you that P external is P2 in irreversible process. So if P2 is 5 ATM, then V2 should be 20 liter. 20 liter, okay? So minus 5 into 20 minus 10. So which is minus 50 ATM liter. Got it? Yes or no? Okay. Now second process, second step, against 2 atm, then again minus the extent is 2. Okay, right? Then volume is changed from, tell me, volume is changed from second case. Now 2 is your this pressure, 2 is your final pressure, and at final pressure it is 20. Okay, at final pressure it is 20. Okay, so I can say that 50 minus, okay, 50 minus, initially, if I'm talking about initially, okay, this 10, so we will get minus 80 atm meter. But if I'm talking about this, first work is done till 5 atm, then till 2 atm, from 10 atm. So this is your work done 1, this is your work done 2. Now if you find this, okay, volume is 50, 20, 10, right? So this is which work done? This is work done 3, W3. Okay. Now, when we talk about W2, W2 should be, W2 should be what? Minus 2 into, tell me, minus 2 into 50 minus 20, which is minus 60 atm meter. Got it? Right? Now, if you see this, total work done, W1 plus W2, W1 plus W2 is how much? Minus 50 plus minus 60 will be minus 110 atm meter, W total. है ना? Whereas worked in one step is minus 80 atm meter. Got it, everyone? Got it? ठीक है? Okay? Okay, everyone. So we'll just see. ठीक है? See this. So the correct answer, right? So for first is minus 50 atm meter, right? Against 5 atm pressure. Then against 2 atm pressure, it is minus 60 atm meter. So total will be sum of both, which is minus 110 atm meter, right? That we studied, Anna. Then if the work is done in one step, it is minus 80 atm meter. Got it? So obviously the work done in one step is less than or more than, tell me, 80 and minus 110. And okay? Now next, everyone try to solve this problem. Question number 10. Everyone's try to solve question number 10. Am I saying that anyone's answer is correct or wrong? Because I'm just explaining you. Okay, I've told you the answer. Please everyone check that your answer is correct or not. Okay, I've already explained it. Question number 10, everyone, please try question number 10. So you have to see, right? It is pressure versus temperature, okay? And it's a straight line. So just think that which process is this? Okay, Sneha, very good. Abhiram, how come delta U will be 0? See, this is P versus T. Just think about this now. P versus T. P versus T is a straight line, right? Which is P is directly proportional to T. Now, when this is possible, when volume is constant, yes or no, right? So, volume is constant because when volume is constant, so P will be nR by V into T, where nR is constant. So, this straight line is of this equation when volume is constant. So, if volume is constant, then it is your isochoric process. For isochoric process, W is equal to 0, right? And delta U, we know that delta U is NCV delta T. Doesn't matter which process it is. Okay, delta U is always NCV dt. Okay, right? Now we know that delta T is 100. Okay, delta T is 100. So work done will be 0, and delta U, unless and until it is isothermal process, delta U will not be 0. So delta U is NCVDT. So delta U will be N is equal to 1 into CV is, tell me, monoatomic gas. So 3 by 2 R, right? And delta T is 100. 100. Okay. So this is 150 R. Delta U is equal to 150 R. Okay. Delta U is equal to 150 R. Got it, everyone? Now we know that delta H I haven't taught yet. Sneha, what is the formula for delta H? Tell me, what is the formula for delta H? Sneha, what is the formula for delta H? Yes, delta H is equal to N Cp delta T, right? Doesn't matter whatever the process. At constant pressure, Q is delta H. So N is equal to 1 and Cp was, since Cv is equal to 3 by 2, Cp is 5 by 2. So it will be 1 into 5 by 2R by 2R into 100. Got it? So 250R. Okay. Very good, Sneha. Everyone got this? Right? Everyone got this? Okay? Everyone? You understood this? Tell me. Any doubts? Are you getting how to solve these problems? See, this is just the formula. We know that the graph between pressure and temperature is a straight line. If it is a straight line, it is your isochoric process. How come we know that this is an isochoric process from the graph. Okay. Now, if it is isochoric process, work done will always be zero, right? Work done is always zero for isochoric process. Okay. Now, if work done is zero, then delta U, okay, delta U is equal to Q, right? Because delta U is equal to Q plus W, right? So W is zero, so delta U is equal to Q, okay, right? So delta U is NCV dt, where N is 1 mole, so it is just CV delta T, and delta H is NCP delta T, okay? Got it, everyone? Okay, very good. Okay, so I guess we have discussed all the processes except adiabatic process. Okay, so we will start adiabatic process. Right now, see this adiabatic process. So we know that in adiabatic process, delta Q is equal to 0. Yes or no? Right? Delta Q is equal to 0. Right? Yes. Okay. Now, there are two methods to find the work done. Right? Now, the first method is using first law of thermodynamics. We know that delta U is equal to delta Q plus W. Yes or no? Tell me, yes or no? Right? So I say that delta Q is equal to 0. In adiabatic process, delta Q is equal to 0. So work done should be equal to delta U. Yes or no? Work done should be equal to delta U. Okay. Now, this delta U is equal to NCV delta T. Okay. Now, whatever I'm doing, this has nothing to do with process, right? Either it is reversible or reversible, because doesn't matter if the process is reversible or irreversible, you can write this expression. Yes or no? This will be true for both reversible and irreversible. Yes? Okay. So I can say that this is equal to N. Now CV, I'll write CV as CV delta T, which is T2 minus T1. Now we know that there's a constant called as adiabatic constant, which is like gamma, which is equal to Cp by Cv. Yes or no? Tell me, yes or no? And there's one more relation, which is Cp minus Cv is equal to R. Okay? Now, can you convert Cv into gamma and R? Now divide everything. Here divide everything with Cv in this equation. By Cv, by Cv, by Cv. Okay? Right? So Cp by Cv is gamma. Cv by Cv minus 1. This is equal to R by Cv. Yes or no? So Cv is equal to R divided by gamma minus 1. Yes? Tell me, yes? Everyone is getting this? Okay, can I write Cv as R by gamma minus 1? So we will get NR T2 minus, sorry, it is T1. Which part I just wrote? Cp minus Cv is equal to R. Divide everything by Cv. Cp by Cv, it is gamma, gamma. Cv by Cv, 1. R by Cv, R by Cv. Then we just cross multiplied. Gamma S1 will go this side and Cv will come this side. So CV is equal to R by gamma S1. Okay. So I just replaced CV with R by gamma S1, gamma minus 1. Got it? Everyone got this? Now we know that nRT2 minus nRT1 by gamma S1. What is nRT2? Can I say that nRT2 is P2 into V2? P2 V2? Yes or no? And nRT1 is P1 V1, and this is gamma S1. Okay, everyone got this? Right? The meeting will end in 1 minute, so please join again. So I hope all of you understood this formula for work done. Yes or no? Right? Now tell me, this formula will be true for reversible process, irreversible process, or both? Tell me, reversible process, irreversible process, or both? If it will be valid for both, then what is the difference? What is the difference between work done in reversible process and irreversible process? Because formula is same now, right? If formula is same, then someone can think that says formula is same, then work done should be same, right? But how can work done in reversible process will be same as work done in irreversible process? It's not possible now, right? So what will be the difference? Because formula will be same, right? Because NC